So we have proved Wicks theorem for two operators. So it says that the time-ordered product of two interaction picture operators is given by the normal ordered product of those same operators plus the contraction between these two operators. And the contraction is nothing but the Feynman propagator. Now, we want to prove a version of Wick's theorem for more than two operators. So let us first state what Wick's theorem is for more than two operators, or general number of operators. So Wick's theorem, say for n operators, will be given by, says that the time-ordered product of n operators is given by the normal ordered product. It'll contain several terms. One of the term would be the normal ordered product of all those operators. And then there'll be all possible contractions. So what do we mean by all possible contraction? So let me give you a couple of examples. One example of a statement of Wick's theorem would be if you had time-ordered product of, say, three operators. By the way, when I denote phi I, by phi I, I'm denoting the interaction picture operator at space-time point xi. So this is a shorthand notation. So coming back to the time-ordered product of three operators, this will give us the normal ordered product of those same three operators plus all possible contraction. And now because we have three operators, there can only be one contraction per term because contractions are always between two operators. So we'll have phi 1 and phi 2, a contraction times phi 3. And then we'll have phi 1, phi 2, phi 3, and the contraction between phi 1 and phi 3. And then we'll have phi 1, phi 2, and phi 3, and the contraction between phi 2 and phi 3. So this is Wick's theorem for three operators. So recall that phi 1 and phi 2, the contraction, or phi 1 and phi 3, the contraction is just the Feynman propagator. So this means that, for example, this term, phi 1, phi 2, phi 3, with phi 1 and phi 3 contracted, is nothing but d of f. Actually, let me just do an intermediate step. This is the same thing as phi 1, phi 3 contracted times phi 2. And then, of course, this is nothing but the Feynman propagator. So this was the case of three operators. Let's look at another example where we have four operators. So it's a time-ordered product of phi 1, phi 2, phi 3, and phi 4. And then here we have the options of making one or more contractions. So Wick's theorem, according to Wick's theorem, the first term would be just the normal ordered product of phi 1, phi 2, phi 3, and phi 4. And then there will be terms which will have only one contraction. So contraction between phi 1 and phi 2, and there'll be normal order product between phi 3 and phi 4. And then other terms with only one contractions. And then there will be terms with two contractions, and such terms will be, say, phi1, phi2, and phi3 and phi4. And there'll be two other terms. One will be phi1, phi2, phi3, phi4, where we contract phi1 and phi3 and phi2 and phi4. And there will be another term which is phi1, phi2, phi3, phi4, where phi1 will be contracted with phi4 and phi2 with phi3. So these are examples of Wick's theorem for 3 and 4 operators.